Okay, so I grabbed this out of one of our junk drawers, and it didn't work. And there are batteries in there, but I'm assuming the batteries are no good. But there's a way to test this without actually, I couldn't find AAA batteries. There's a way to actually test this to see if it works without having AAA batteries. Now, one of the things that I have is this here converter. It's plugged into power. It's on now. You can move this dial and change it between 3 volts, 4.5, 6, 7.5, 9, and 12 volts. This is just something I've had for quite a long time. It came out of a classroom. I'll show you a different thing that I got because you probably don't have one of these laying around, but I did. So a couple different ways that you can test this. One of the things that you really need to know though is how batteries work. So these are DC batteries, direct current. So it's always the same amount of current. It doesn't alternate like plugging into a wall. So we're just talking about DC, low voltage DC. So when you look at something and you see the batteries are going different directions, what actually happens is it takes all the different voltage of the battery and adds it together. So it's called series or parallel. Parallel, if you put two batteries, I'm just going to use this together like this, and you connect in. If you connect them together and then you check the voltage on both sides, the voltage will remain the same. So these are 1.2 volt batteries. The voltage will be 1.2 volts, but what you do is you expand the capacity so they can last longer because you're putting two batteries together. Now if I do this, that's a battery in series. And a battery in series takes the 1.2 plus the 1.2 as long as these are fully charged, and now you have 2.4 volts. It's really, really important. That, by the way, is how battery packs work. So this is a 12 volt battery pack. It's made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 AAA batteries. And they're flipped. So positive to negative, and it goes like this. So it's 12 volts, but all these battery packs are that you have in different things, it's the same concept. It's just using these batteries and orienting them a certain way. So this is a 12 volt battery pack. This has 1,000 milliamps. So because these batteries are smaller, they won't last as long. So the size gives you more capacity, but not more voltage. So it stores more energy, it lasts longer. And you can see with this one, these are D-size batteries, and you can see they're soldered together. This was a large battery pack that I took apart. So you can see from here, it goes this way, over, down, over, up, over, down. So if we test this, I don't even think this is charged. So we can test it right now, and this should be, I have it backwards. It's 1.84 volts. Because of how this is in series, these are all 1.2 volts. You can see right there, 1.2 volts. 1.2 times 4 is 4.8. I'm pretty sure my math is correct there. So this should be 4.8 volts, so that tells me this needs charged. These have just been sitting. But you can see that's how you would measure the voltage there. So why did I go into all that? Because I need to know what battery, what voltage this requires. So I have 1, 2, 3, 4 AAA batteries. And AAA batteries, by the way, rechargeable batteries are rated at 1.2 volts. These batteries are rated at 1.5 volts. So if you're trying to use recycled batteries, rechargeable, not recycled, rechargeable batteries in a device and it doesn't quite power it up or act right, it's because that device needs that that extra voltage. I've had that happen multiple times. So like calculators, things like that, usually rechargeable batteries don't work as well. So this requires 1.5. This is also around way before rechargeable batteries were really a thing. I mean, they were a thing, but not used commonly. So I'm going to go 1.5 times 4, which is 6. Pretty sure that math is correct. So I know this needs 6 volts to be able to go. So I'm going to set this at 6 volts. Now the other thing I need to know is where to measure it from. So this is where it comes in negative. So I'm going to go ahead and do this, and this is where it comes out finally positive. So I'm going to go ahead and do this. Maybe. This is going to be kind of hard to do. And then I'm going to see if it turns on. And I'm going to be wrong. 6 volts, 1.4. I gotta think about this for a second. That goes that way, comes over, goes back. That should be how that works. Let's make sure I'm getting the right amount of power from this. Yep, 6 volts, so that's working. So either there's something wrong with my math or something wrong with how these are all connected. Alright, so I remember doing that the last time too, and I thought, hey, I want to go here and here because that's where it comes in and goes out, but that's not actually true. How you know that is you see these two are connected and these two are connected. You want to look for the ones that aren't connected. They're isolated. So see this here? That's isolated from everything else, and so is that. So that allows it to come this way, through, and then through this way. So let's put it on those instead and see what happens. There's the negative. And here's the positive. Oh, sorry. This one's hard because I can't. I have to just kind of hold it there. And you see, can you see that? You see that this says memory cleared, but it works. So I know now, before having to buy batteries for this, that if we want this to work, we just get regular 1.5 new AAA batteries, and this is still good. So the other thing that I wanted to show you, so I have this here thing, or in the battery and being able to troubleshoot things concept here. This is solar powered, and it did not work unless I took it out in the sun. And the reason that is, and the reason I'm showing you this, is because this is another one of those things that you tend to throw away because you think they don't work. So I'm going to go ahead and take this apart real quick. And it's possible it doesn't work, but you really haven't tested it until it does. So there's some light in here, so this thing's working because it senses the light, but it's not holding that charge. I'm just going to pop that. Okay, pop that off. You can see this is pretty simple. This is a solar panel up here, right there, that just goes in and provides power when you have solar, any light going to it. So that's what that is. Really simple circuitry. This right here is just the printed circuit board for the calculator, and that's the display. Okay. Right here you see a battery. Well, that battery is what is used when you're not in sunlight, or any light source. Doesn't need to be sunlight per se. So there's your battery. So now you can see no working without that battery. So the battery worked but didn't hold a lot of charge. So what I have here is an L1131. I don't know if you can see that. Stick it in there. Usually the positive, which is the top. How these things work is the top's usually positive and the underneath like that is negative. And almost always, I haven't seen one ever upside down, so almost always the label's facing you when you put it in. I just pried that up a little bit to help me push this in. Bend that back up. Well, that hurt, but I think we're good. There we go. So now we have that. Now if I cover this up, because it's a new battery, it'll still work. But just understanding how this works, will help you. So it's a 1.5 volt. No, I'm sorry. These are 3 volts, I believe. Watch batteries are. Well, this one says 1.34. So this is a brand new one. Let's see what this one is. No, it is 1.5. So these are 1.5. But you can tell this one was only 1.1 or 2, whatever it was. Didn't have enough power. Some of these watch batteries are 3 volts. There are some batteries, that's the other thing, you can't just go by the size of the battery. There are some batteries, like for your garage door opener, that are smaller than this, that are 12 volt batteries. So you always want to check. This is from a phone. You can see this is a 3.6 pack. This is for a portable phone that we don't use anymore. I just kept this just as a something that could be used somewhere else. 1.2 rechargeable times 3, 3.6. So you get the concept. That's how this works. I won't bore you with putting this back together, but just know that that's how the batteries work. How putting them together in series powers motors and things that need more power. If you say had a scooter that you used, the scooter would have battery packs that are bigger than this to have to last longer, but it's the same concept. They're just bigger batteries that are put together in series. So if you have a 24 volt, for instance, a 24 volt scooter, that tells you that there are 20 of these, because 20 times 1.2 is 24. That's what it is. I'm pretty sure. You can check my math if I'm wrong. You get the concept. And the size of this battery, the larger it is, the more capacity it has, which means the longer it can run. It's really that simple. Don't overcomplicate things. It goes from radio-controlled cars, from portable phones to radio-controlled cars, watches, all that stuff. All we're doing is, and all we've done for a long time, is put the batteries in a different format. So you can build your own battery packs. You can do all kinds of stuff. You can test. All right, so here's the thing. I had this laying around, like I said before, I got it from a school. A buddy of mine's like, hey, could you use this? Sure. I didn't realize how much I could use it or how often I would use it. But you probably don't have one of these. So I'm going to go ahead and put this aside. And I want to show you something I found on Amazon, which is really cool and needed for some things I have going on. This is, I don't know, WeFoamy Universal Power Supply. The point is it's a universal power supply. This is the first time I'm actually taking it out of the box. It allows you to do the same kind of thing. You could dial in the voltage. And the other really cool thing about this is, if you're like me and you have power adapters that you've either lost, or maybe you have kids that tend to put things in places you can't find them. Well, just for instance, hypothetical, of course, but things like that happen. Well, this kit, which I didn't know existed till I looked it up, trying to find something that you guys could use, has all these different adapters for all these different styles. So you can dial in the voltage that it needs, and you can use these adapters to charge so many different things. The other cool thing about this kit, and the reason I got this one, is it's got this here thing. And this having the alligator clips built right on allows you to put it pretty much in anything and test like I was doing before. So this was, I don't know, less than 20 bucks. And it gives you all the different options to dial things in. So for right now, let's just test this real quick. So I'm going to, oh, and it gives you granular digital readout. Wow, so you can really dial it in. Interesting. So let's do, it says 7 volts. Let's test this thing out. Do that. And that. 6.9, oh wait, what did I do? Sorry, kind of in a hurry. Close enough, right? Because batteries fluctuate quite a bit. They usually have to get outside of a larger scope to not work. And you can see 6.9. So this allows you to dial in, I believe, all the way up to 24. Yes, and I got this one because there are things that run on 24 volts. For instance, like a scooter, I know it does. Some of them do. There are 24 volt lights, 24 volt LEDs, things like that. So I got the one that goes up to 24, not just 12. Any higher than that, you're talking higher voltage, and that's not a normal thing. But for instance, I'm just doing this on the fly. I haven't even tested this, obviously. But this thing has a really small plug, and it broke last week. So I have no way to charge this other than the USB, which is really slow. So what I'm going to do is, oh, and by the way, USB, I don't have one with me right now, but those USB chargers, where's the one that I had? USB chargers usually 5 volts to charge. Just trust me, you can look it up. But that's what it is. So this should be a 5 volt scenario to charge this this tablet. This is an old tablet, so I'm not going to buy a whole new thing. But the first thing I'm going to do is see if one of these fits in that little hole, which is really a weird one. Nope, not that one. It doesn't seem like the right fit, but it's super tiny. And I've never seen one that small. Oh, holy crap. So let's do this. We're going to put this to, what did I say, 5 volts? I'm just going to turn the dial, put that to somewhere around 5. I definitely don't want to overcharge it, over to it. I'm going to put this in, and that blue light it already did. Do you see the blue light? Right there? So that blue light means it's charging. So now I can use this charger to charge something that I would otherwise not be able to. Really cool. So this is called a universal power supply. Again, it goes from 0 to 24 with the digital dial to dial it in. I got this one for myself because of this. It allows me to pretty much do 0 to 24 volts on anything, but it's got all this assortment of connections, including USB-C and all of those. And one of them fits this. So now I have a way to charge this device without having to go buy a $30 adapter or whatever it is. So very cool thing. If nothing else, in this video you learn about that, and that's something you can get and go from there. So just wanted to share all that stuff with you. I think there's quite a bit there to know, but it's also pretty simple. And that's a lot of the times what we try to do is take these really complicated things and simplify them down, because it's really the best way to know how things work. So hopefully this helps. Thanks for watching.